All right, so our next speaker is Raphael Mazor from Southern California Coastal Water Research Project. Raphael has a doctorate from UC Berkeley, another UC, so in the family, but not the same. So he works on stream survey for Southern California Monitoring Coalition, Stormwater Monitoring Coalition, and other projects, and he's nice enough to come up and speak today. So thanks, Raphael.
Thank you. Great, so we've heard from Andy about some of the tools that the state's developed to assess water quality, and Betty's mentioned a few others. And I'm going to talk a little bit about how agencies, both within the water boards and outside, are actually using these types of data for various programs. Actually, what I did is I just had a bunch of phone calls with a bunch of people and asked them, how are you using bioassessment data? How would you like to use bioassessment data? Where do you see it fitting into your program? And so what I'm going to provide you today is an overview of these programs that isn't exactly by SCWRP, but SCWRP has been involved with. And actually, a number of those agencies are represented here today. So I'm hoping that if you guys have questions, that some of you guys will just happily stand up and share what your agency is doing. So as Andy mentioned, we have a lot of tools to assess biological condition. We have tools for benthic invertebrates, diatom, soft algae. We have a riparian wetland condition tool. And we also have a number of programs that are starting to generate a huge amount of data. So what are we doing with all this? How can we move beyond just simple assessment? So when I spoke to different agencies, they all identified a number of common objectives. They want to characterize their region. They want to know which water bodies are their healthiest, which ones they should be fixing. They want to use bioassessment data to figure out what's causing all these problems. And they're actually starting to use this in a variety of different programs, including permits for stormwater discharge or agricultural programs. So it's actually starting to get used more and more across the state in a number of different programs. The key is that bioassessment data really can support a whole variety of different objectives. One of the more high-profile ones is basically what Betty was talking about, that bioassessment data will be sort of the cornerstone of the state's combined biointegrity and nutrient policy. We basically have tools now that we can use to measure the biological integrity of our streams, at least our wadable streams, and we're expanding to other water body types as well. And we're going to be using these to establish numeric endpoints for nutrients using things like algae index scores or even bug index scores. Betty talked a lot more about how they respond to different types of nutrient concentration. So these will be a much more effective way of figuring out what levels of nutrients support healthy streams. But one of the aspects I want to talk a little bit more about is this characterization, using bioassessment data to figure out how healthy your region is as a whole. Andy talked a lot about the perennial stream assessment, but there's also a lot of surveys going on at a regional level. Some notable examples are the Southern California Stormwater Monitoring Coalition program. The Bay Area has its Regional Monitoring Coalition. With Central Coast, there's a Cooperative Agriculture Monitoring Program. And these programs are all generally driven by permit compliance. So you have regulated agencies that are collecting this data in order to comply with some of their discharge permits. But they also have these other goals of really helping regulators and the regulated permitted agencies really start talking together, collecting data together and agreeing about what it means. So these regional monitoring surveys really have a really good outreach component to them. But I do also want to highlight, this is something that Betty touched on a little bit, these programs are actually major data engines for a whole lot of other endeavors. They generate hundreds of sites every year, and we can use this to further a whole wide suite of other objectives. I'm going to talk a little bit more about the SMC program. It's the one that I'm most involved with, so I'm most familiar with it. The SMC program, it's the Southern California Stormwater Monitoring Coalition. It's a collaborative program made up of some of the lead stormwater agencies in Southern California, as well as regulatory agencies. And we started in 2009, basically as a Southern California chunk of the perennial stream assessment. We wanted to figure out what's the best way to collect data to answer questions that was of shared concern of all the different partners. We wanted to know what was the condition of streams in our region. We were focusing initially on perennial wadable streams. We wanted to know for streams that weren't in poor condition, what stressors are causing that. And finally, we want to know if conditions are changing over time. We completed our first 5 years of sampling in 2013, and we're actually able to get some answers to these questions. For example, we know that in Southern California, about 25% of our stream miles are in good shape when you look at all four indicators: bugs, diatoms, soft algae, and riparian wetlands. On this map, that's shown by those blue dots, and those are largely located in the interior highland areas, the mountainous, undeveloped parts of the region. In contrast, there were a number of sites where none of our indicators showed good health. These are those red dots on the map. These are focused primarily in highly developed urban areas. So this really gave us a first cut effort to prioritize which areas we should be focusing on for protection or restoration. Because this was done as a probabilistic survey, we're able to really get similar answers for just small portions of our watershed where we had enough data density. And so for each of the three regional boards within the SMC, we're able to easily highlight watersheds that were where streams were relatively healthy or relatively unhealthy. And so you can see within each region, there's at least one watershed where the majority of streams are in good shape, and another where most of your streams are in poor shape. Those red dots are those red squares are those where there's very few healthy streams in each of those watersheds. And we're also able to prioritize not just water bodies, but we can start prioritizing stressors. This is actually using a similar analysis to what Andy talked about with relative risk assessment. What we found in the SMC program was that there were certain stressors that were fairly widespread and strongly associated with poor biological condition. These were nutrients, major ions, and degraded physical habitat. In contrast, there were a few other stressors that were either fairly restricted in their distribution or weakly linked with biological condition, things like metals or pyrethroids. And that really helped change the focus within the SMC. In the past, we'd really largely focused on contaminants where we had available criteria that we knew we had to meet some standards from the California Toxics Rule. But there was a whole suite of stressors out there that might not have a clear standard that we need to meet, but were clearly very important for supporting healthy streams. So this really helped shift our focus a little bit. In terms of trend assessment, we didn't see a lot of change over time. And in some ways, this is a good thing. These trend assessments are actually probably the most important aspects of what these programs do. They tell you how effective all of your water management programs are working. If they are working, you'll see this line go up over time, or at least not go down. So in some ways, this lack of a trend is a little encouraging, but we're currently revising our program to really get a better insight into whether these trends are occurring, and there just takes more time to see them. So characterization is really just the first, So we're actually also focusing on trying to disseminate the information that we have from this program. We've got a number of reports that we've published. We've summarized the results from our 5-year survey in a large technical report. But to reach out to a general audience, we've put together a fact sheet. This was done in collaboration with the Water Board. And we're going to start putting out reports on a more annual basis. Our upcoming one will be focusing on the conditions of engineered channels, similar to what Betty was showing you earlier with the results in concrete channels versus non-concrete. So if that's a subject that interests you, you should keep an eye out for this later this year. So characterization of your region is really one of the more fundamental steps you can do with bioassessment, and really lets you pursue a number of other objectives. One of the most common objectives I heard different agencies mention that they're really interested in is protecting their healthiest streams. And one of the mechanisms that the State Board is doing this is through these Category 1 listings. A Category 1 listed stream is a stream that that supports all of its designated beneficial uses. And so the State Board has started pilot studies in a number of different regions throughout the state. And it's actually pretty interesting to see how this is going to work out in all these different places. We're mostly focusing on CSCI scores, but we're also looking at things like land use data and other evidence to see whether or not a stream is likely to meet Category 1 criteria. And so in a region like San Diego, where development is fairly pervasive, you might have a certain set of mechanisms to help protect these Category 1 streams, and you might use something different in the Sierras, where reference streams are somewhat more common. It's not just the regulatory agencies that are interested in using biological data this way. We've been working with the city of San Diego to help them identify watersheds, catchments in the San Diego River watershed for protection. The San Diego River is actually one of the major sources of drinking water for the city of San Diego, which is why they were so interested in protecting it. Working with SCWRP, we've been trying to establish biologically based thresholds for hydrologic alteration, so we can identify when flow alteration is likely to be minimal enough to support healthy streams versus when it's likely to cause degradation. So on the map on the left, you see, on the left side, you see that these yellow and green watersheds, those are watersheds that there's been minimal hydrologic alteration and still are likely to support healthy streams. But when you look at the county's plan for development, there's actually quite a bit of development planned, even in the upper watersheds here. And you can project how the flows are likely to affect future biology. So this is, you can see you've eliminated all of your green watersheds. Those are the healthiest ones. And so you're likely to cause a lot of degradation to their drinking water supply. So the city of San Diego wants to use this type of information to focus their conservation efforts. If you have an unhealthy stream, of course, you need to figure out what to do to fix it. And that really requires what we call causal assessment. As part of the biointegrity policy development, the state engaged in a number of case studies throughout in different parts of the state. One of the major lessons that we learned from causal assessment is that it's a very difficult process. It can take a lot of time and requires a lot of data. And so there's a lot of interest in figuring out ways to make this easier for people to do, particularly on a large scale. We've been working with the Santa Ana Regional Board in refining the causal assessment approach. Again, we're trying to figure out why you might have low CSCI scores at one site, what stressors are associated with that. But rather than looking at just at a site-by-site level, we're trying to do it on a slightly more regional scale, where you can look at impairment at a whole reach level, and you can look at comparator sites that are coming in from all over your region, not just in your immediate watershed. Ultimately, we hope to have some tools that'll help you quickly screen through a number of plausible stressors and see how they relate at your test sites and your comparator sites. And I actually think that talk we heard from Grant gave me some ideas of how we might want to start making these tools more accessible to people. These tools are, this approach is possible largely because the Santa Ana region had so much sampling under the SMC and PSA programs. So there was really a large data set to work with here. Several agencies mentioned looking at biological data to help prioritize areas for management intervention, in particular supporting the TMDL process. In the Bay Area, there are several listings throughout the state where they're already using bioassessment data. And in the Bay Area, Kevin Lundy mentioned Arroyo Las Positas as being one of those primary examples of where they're using data they collect during their bioassessments to support this listing. However, it's not the only example. There are several regions throughout the state where this is happening right now. Again, it's not just the regulatory agencies that want to do this. Orange County has, for their water quality improvement plan for San Juan Creek, they've identified regions of this watershed where where they're prioritizing areas for intervention based on low CSCI scores. They'll be following up these prioritizations with causal assessments, focusing mostly on hydromodification. A few agencies are right now trying to develop objectives for bug and algae indices, particularly the LA and San Diego regions, focused on the California Stream Condition Index. Region 9 is a little further along on this process right now. They're using the CSCI as a numeric interpretation of narrative objectives in their basin plan. They may also be looking at algae indices too. They have about 28 streams proposed for listing for benthic community effects. And while a number of these streams are already listed for other impacts like toxicity, this does mean that there will be a few new streams added to the 303D list based on CSCI scores. Another application we're interested in is site-specific impacts, and this can be best exemplified through 401 certifications for stream bed or wetland alteration. And one good example I want to talk about also comes from the Santa Ana region. The Santa Ana watershed is home to an endangered fish, the Santa Ana sucker. And right now, a lot of its populations are dependent on the elevated discharge from treated effluents. However, given the drought, there's a lot of competing interest in that water. So in order to redirect that treated effluent for other uses, the Orange County Water District is interested in manipulating the habitat to help maintain high velocities with less water that would presumably support the Santa Ana sucker. However, what would the effect of those manipulations be on the rest of the ecosystem? Well, to do that, we're actually going to be using our bioassessment tools. Again, the Santa Ana board is using the data from the SMC program as a baseline data. They had a lot of sites sampled in the project area. And they're going to partner with the permittee to collect bioassessment data after the project is completed and use that to evaluate whether the project has had a positive or negative impact on the stream ecosystem. San Diego's doing something similar. They had a 401 certification for some dam removal in San Juan Creek. And in this case, the permittee is the one who's actually going to be doing all the assessment, but they're going to be using CSCI scores as a baseline for future compensatory mitigation if they find that there's been a negative impact. So I asked all the different people that I spoke with, what is really their biggest obstacles to using bioassessment data more widely in their programs? And there's a number of major topics that they identified. They wanted to see more tools. For example, if they're not in Southern California, they're not really confident about using an algae index. They collect a lot of habitat data, but they're not really clear on how to interpret it. So they wanted to see something like a habitat index. Far and away, the most common thing I heard was that people want to have better data aggregation, particularly for data collected outside the water boards, and better access to data. And this can be accomplished through some better tools for downloading, but also just more trainings and outreach and just to know where are all these data available. They'd like to see more coordination among different sampling efforts in a region and also better guidance for permits. I'll tell you, fortunately, on each one of these items, the state board is actually undergoing a number of projects to really target each one. So it's actually a really good mix of where our efforts are expended and where they're needed. So I just want to close by saying that bioassessment data really can support a large variety of water board programs, or I should say water management programs, both inside the water boards and outside. There's really a common vision out there to see biological data used to inform resource management. There's a lot of different agencies out there using the data, and there's a diversity of ways that they plan on doing this. And I think that there's a lot that we can learn from this experience. There's going to be a number of successes and failures out there. And so I'm just putting this out there as a call that people really advertise the lessons that they learned by sharing their experiences and stories through a variety of different formats. And with that, I just thank you and open up to questions, which I'm hoping that the folks in the audience will feel free to answer as well. Thanks.